All right, so you found a quick review here, and this is classifying equations and functions. So it's important that you're able to look at the math there and determine, hey, what is this? What kind of thing is this? Okay, so the first thought is you have to understand the degree. It's the first thought. So if you look at this, remember the degree involves the exponents of the variables, and that's a 1 exponent, right? We don't show it, but it's a 1, and therefore the degree is first degree, and any first degree equation is linear. First degree is linear. So if you look at this second example here, notice again, we have two variables this time. We have a y and an x, but both are to the first power, and therefore this is still a first degree. So first degree makes it linear. First degree makes it linear. All right. Second example here. Now we have a squared variable. Right? We've got a squared variable, and so this is second degree, and second degrees are quadratic. So second degree quadratic. And there's another quadratic. Again, understanding that this squared involves that variable right there. Now, by the way, we've got a number cubed. It doesn't matter what the exponents of the numbers are. That's just 125, right? But it's the variable's exponents, not the number's exponents. So this is second degree, and therefore it is quadratic. All right, so here's an example. In this one, again, all that matters is the variables of the variables, and highest variable or the highest exponent is 3. And so therefore this is third degree. And the reality is, if it's third degree or higher, we call it polynomial. Polynomial. So third degree or higher. And here's another example of a polynomial. All right, it's fifth degree. You see that 5 there, right? So this is fifth degree. I'm going to give you the fifth degree. Maybe that's the third degree. But anyhow, fifth degree, and therefore this is going to be polynomial. Okay, so the degree determines linear, quadratic, polynomial. First degree linear, second degree quadratic, third degree or above polynomial. Okay, so what's the other thing you got to figure out? Okay, is it a function or is it just an equation? And it's by how many variables? So you look at this first example now. Let's go back. We're right here. How many variables are there? And you should say there's only one, just the x variable. So guess what? Anytime you have one variable, it's an equation. All right, so stay with me. Look right here. How many variables? Well, you might say 2, but no, it's an x variable. Whether it's in 2 places doesn't matter. The variable is an x. So there's just one variable here. All right, and so again, this would be an equation, this time a quadratic equation, because it's second degree, one equation. So one variable, and therefore equation. So quadratic equation. If you look now at this third one here, this one right here, again, notice just one type of variable, one kind of variable. Again, that's why I say different variables, just one variable. So again, this is going to be an equation. One variable is equation. Because it's third degree or above, it's going to be polynomial equation. So okay, then how do you tell if it's a function? Two different variables. So look at the first highlighted one in tan, right? Aren't there two variables? Okay, two different variables, x and y. It's a function, linear function. Second one down here, two different variables, again, x and y. And guess what? It's a function, quadratic function. Now the variables don't have to be x and y. They could be r and t, rate and time. They could be distance, d and t, distance and time. They could be acceleration and time, acceleration and distance, all kinds of different possibilities. And again, the third example, notice two different variables, therefore function. So the degree tells you whether it's linear, quadratic, or polynomial. And the number of different variables tells you whether it's an equation or a function. All right, get that down so that you can identify and classify equations and functions.